Good afternoon, everyone. Today we are going to present our project, A Peacemaker. The members are Nicole Prieto, Elizabeth Palacios, Daniel Suarez, Isabela Garcia, and me, Edwin Silva.
Now, when you look the montage of this project, we clarify that this project is not medical, it's a simulation and this cannot measure your really cardiac frequency.
If you press the sensors detect your pulsing and project in the Arduino graphic. You can see that the caudal decrease, but if you don't press the sensor, the caudal increase.
You can see that the graph is to see periodic wave before pressing the sensor, but then when pressing the sensor, you can see that the waves are not periodic.
For that reason, we decided to calculate the caudal with the continuity equation and the Bernoulli's equation. This project explores the interaction of a pacemaker with the topics covered in the Fluids and Waves course. A pacemaker is a medical device that generates low energy electrical impulses to regulate heart rate and rhythm by facilitating the propagation of electromagnetic waves in cardiac tissues. Throughout this study, the phenomena of wave propagation in biological media are analyzed, evaluating how the characteristics of the tissue affect the frequency and amplitude of the impulses. The project also examines the influence of pacemaker on blood flow, specifically on the pulsatil flow that depends on the heart rate. To do so, principles of the fluid dynamics, such as the continuity equations and Bernoulli's equations, are applied to describe blood flow and pressure.
General objectives. Analyze the functioning of a cardiac pacemaker from the principle of a fluid and waves, evaluating how electrical impulses affect blood flow and signal transmission in cardiac tissues. Specific objectives. Determine the propagation characteristics of the electrical waves generated by the pacemaker. Examine the pacemaker's heart rhythm in the blood flow, applying the continuity equation to describe changes in pressure and flow velocity in the cardiovascular system. Evaluate what factors affect the transmission of electrical signal from the pacemakers.
The theoretical framework is composed of different points, which I will discuss below, starting with the pacemaker. The cardiac pacemaker is a medical device designed to regulate the heart rhythm by generating controlled electrical impulse. This impulse simulates the muscle fibers of the heart, causing them to contract and ensuring a proper heart rhythm. The pacemaker electrical waves are low frequency, designed to stimulate the heart without damage it. Their propagation depends on tissue properties such as resistivity and permittivity. Propagation velocity equals lambda divided to time. Pacemaker signals are characterized by their rate, generally in the range of 60 to 120 pulses per minute, equivalent to 1 to 2 Hz. The signal frequency is equals when divided to time. The typical range is 60 Beats divided in 60 seconds equals 1 hertz. And 120 bits divided in 60 seconds equals 2 hertz. The amplitude is voltage peak to peak divided in 2. In Peacemaker, the amplitude is related to the peak voltage of the signal. This feature ensures that the simulation is effective and specific, promoting synchronized contractions of the heart. Electrical properties of cortical tissue. Cortical tissue has electrical properties that are key to its function. It is composed of specialized cells that generate and transmit electrical impulse. Its conductivity is anisotropic, which means that the speed of propagation varies according to the muscle fibers. These characteristics, together with the conduction system, ensure the efficient and rhythm contraction of the heart. Fluid dynamics, cardiovascular system. The cardiovascular system is dynamic, with blood driven by the contractions of the heart through vessels in a pulsatile flow. The continuity equation explains how flow Q depends on area A and velocity v, showing that blood moves faster in narrow vessels and slower in wide vessels for efficient distribution. Bernoulli's principle, which relates pressure, velocity, and height in fluids, describes how heart rate and pressure during systole affects blood flow velocity. Heart rate. Heart rate, HR, is the number of beats per minute, BPM, and determines the pulsative blood flow. Cardiac output, Q, is calculated as Q equals F per volume. If the heart rate is 70 bpm and the systolic volume is 70 milliliters per beat, Q equals 70 beat meter per 70 milliliter beat equals 4,900 milliliters minute, and this is equals 4.9 liters minutes.
Mechatronical engineering is now for developing systems that can perform tasks autonomously or semi-autonomously, improving the quality of daily life through efficiency. An example of this can be seen the Peacemaker project. A pacemaker is a medical device helped by sending electrical impulses to the heart, which applies this in the following way. Since the project is developed with Arduino, it involves both hardware and software, creating a system with sensors, controls, and motors, which make it an automated system. The use of hydraulic is demonstrated through the pressures needed for the circulation simulation, and the control aspect is handled by the Arduino programming, which sends impulses to the pump blunt, in this case water. Modeling and simulation of the Peacemaker using Arduino server as a platform to simulate the behavior of the complex mechanical systems with help of the sensors and actuators, and then model these behaviors to flaws or necessary adjustments.
Functioning. This project works thanks to an internal generator that emits electrical impulse when the heart beats too slowly. This is impulse transmitted through electrodes stimulate the heart to beat at a normal rate. Basically, it is like a pacemaker for the heart, ensuring proper blood flow. First, using Arduino hardware and software, we want to create a system that simulates the operation of a here pacemaker. For this, the here of the project is the Arduino Uno. This microcontroller is responsible for processing the data collected by the XT158C here rate sensor. In addition, they using an 16 times 2 LCD screen with an I2C and 12 volts minimum pumps. The R219H bridge and 12 volt supply. Finally, the montage that we can see on the screen were used for the construction of this project. For the software, the sensor was programmed so that when it detects a pulse it would send impulse but at a slower speed when the water came out. But when the sensor did not detect pulse, it would send impulse with the maximum speed. We can see with the graph above when it does not detect and the graph below when it detects a pulse.
Conclusions. To conclude, we can agree that the pacemaker is a device that was saved hundreds of lives and increased the life expectancy of many others. Moreover, it is a technology that can be further developed within the field of mechatronic engineering by approaching it from the perspective of fluid and waves. We can interpret how our heart functions and also identify ways to address any anomalies what may arise in it.